So the last thing that we're going to do for today is a cotangent. So here's cotangent. Now it says over this interval, and you might see instructions like that in the book. Again, I'm just going to fill up my graph as much as I can. So here we have our vertical stretch factor is 4. Our period is pi over b. Now b in this case is -1, but that's not, like a period being negative doesn't make sense. So it's really just divided by 1. In this case, that's the period is still pi. I mean, technically it comes out to -pi, but going pi to the left or going pi to the right doesn't really matter. And our phase shift is going to be pi over 2 to the right. Now this negative does have significance here because it is flipping my graph horizontally. It's mirroring it horizontally over a vertical line, which actually means that since cotangent normally goes high to low, like this, between the vertical asymptotes, flipping it horizontally actually makes it look like this. And that makes it look like a tangent graph. Okay? So that's going to be the significance of this negative inside. But other than that, everything else is going to be exactly the same. Now, cotangent normally has a vertical asymptote when the inside is equal to 0 or pi. And so that makes solving this really simple. If I set what's inside equal to 0, then dividing by a -1 doesn't change anything. It's still 0 over here. And if there were any number here, if the period had changed at all, if it was stretched, if it was compressed, it's not going to change the 0 that's on the other side. And so just for cotangent, not for tangent, and not for any other trig function, the location of the first vertical asymptote is always going to be the phase shift. But just for cotangent. So if trying to remember that it's just cotangent where this phase shift is equal to where the vertical asymptote is, if that's going to be confusing, just set what's inside cotangent equal to 0. You could also set what's inside cotangent equal to pi. Okay? And when I do that, you'll see if I divide by a negative here, I get x minus pi over 2 equals -pi. And then when I add pi over 2, I get x equals -pi over 2. And so my next vertical asymptote would be at -pi over 2. And notice the distance between these two vertical asymptotes, the distance between them is pi, and that is the period of this function. Okay. Now taking that distance between the vertical asymptotes and dividing it into 4 equal parts gives me pi over 4 as a distance between key points. So this is the distance between my key points. And this distance, pi over 2, so 2 pi over 4 is pi over 2. It matches up with my phase shift, so again, I can use this as my scale. Okay? So we have all the pieces in place here to graph this. And what we're graphing this time is y equals 4 cotan of -x minus pi over 2. And we said pi over 4 is going to be our scale. So this is pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4 gives me 2 pi. Do the same thing in the negative direction, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4, and negative 8 pi over 4. We have a vertical stretch factor of 4 here, so I'm going to make this 4, negative 4, which would make, again, I don't have to label the rest of this, but that's 8 and 12, and this is negative 8 and negative 12. And we were told that our first vertical asymptote is going to be at pi over 2. We have another one at negative pi over 2. So at pi over 2, we have a vertical asymptote. Here it is. We have another vertical asymptote at negative pi over 2. And then any pi over 2 away. So pi over 2, or pi away from pi over 2 is 3 pi over 2. So this distance is pi here. And then we have at negative 3 pi over 2, we'd have the same idea here. Okay, and notice that we have 8 boxes apart, 8 boxes apart, 8 boxes apart, all the way across. And that is what we're looking for. We're looking for that pattern. So normally cotangent starts high, so at 4 and then 0, and then, so it would normally go 4, 0, and then negative 4. But because of this negative inside, it's actually going to be starting, it's going to be mirror imaged vertically, horizontally, which I drew previously. And so that would look like this. And that pattern is just going to repeat. And you might be thinking to yourself, hey John, this looks very much like our original tangent graph. And yes, that's exactly what this is, except it's vertically stretched by a factor of 4. But because of the way that I have created my scale, this does look exactly like tangent of x. And there we are. And that's actually a trig identity, this part right here, is that this is equal to tangent of x. So this whole thing would be equal to that, which is kind of cool. And we'll talk about trig identities at a later date, after the next exam. Okay, so please do the problem set on Blackboard, submit it before the due date. Reach out with questions via email before that if you have them. Let me know if you're struggling with anything, if you can't access the content. I haven't heard back from everybody in the class yet. I'm afraid that some of you just are not checking your email. If you're not checking your email, you're not getting these messages from me. Also, you should be checking Blackboard. But if you're not checking Blackboard, you're not going to get this message anyway. Please let me know if I can be of any assistance. I want you to be able to finish this semester successfully. I know that this is not the easiest content to learn from afar, and I hope these videos are helping. And just remember that you can replay these videos as many times as you want. Reach out with questions via email. I can always make you a specialized video and send it back to you if you have a specific problem on like a book problem or a previous problem set that you just still don't know how the answer came to be. All right. I hope everybody's happy. I hope everybody's healthy. Stay safe out there.